Hi, Mr. Wright here, and welcome to this walkthrough of January 2020 1F. That's Edexcel IGCSE 1F, the first foundation paper from January 2020. Hit the link in the description and you can download the paper, and then you can work on the paper and then watch the film, or you can be completing the paper as you watch the film and work alongside me. By the way, if you are preparing for your Edexcel IGCSE exams, why not hit like now? Tell me you're watching. If you've got any questions as you watch the film, do leave them in the comments, and of course I'll respond. And lastly, if you are preparing for your Edexcel IGCSE maths exams, then subscribe to the channel. There is lots there to help you. Right, let's get on with the maths. Okay, question 1. The table shows the land area in square kilometers of each of 6 African countries. Let's take a moment, make sure that we understand what the table is all about. Right, write down the name of the country with the greatest land area. So I'm looking for the largest number. Here, it's going to be one of the ones that begins with an 8. It's going to be this one, isn't it? And so the name of the country with that largest land area is Tanzania. Write this number correct to the nearest 1,000. Well, is it going to be 823,000? Or is it going to round up? Well, here's the cutoff point. So it's 823,200, so it doesn't round up. 823,000. Work out the difference between the land area of Botswana, that's this one, and the land area of Kenya, that's that one. So I'm going to do the largest, which is Kenya, subtract the smallest of those two, which is Botswana, to find out the difference between them. So I've written down the sum I'm doing, and now I'm going to put that in my calculator. Just making very sure that I've copied down the numbers correctly, because what you don't want to do is to make an unnecessary error. 2,410 is the difference. And lastly, the land area of Gambia is this. Write that number in words. Well, it's 10,000. And then 120. And that is number 1 complete. Question 2. The bar chart shows information about the weight in millions of tons of bananas produced by each of 4 countries in 2016. Look, I've got information here on India, Philippines. Oh, I haven't got any information on China. I've got Brazil and Colombia. In 2016, China produced 13 million tons. Draw a bar on the bar chart to show this. So I've got to go up to 13 million. Now be careful of your scale. Although this time, look, the scale looks okay, doesn't it? So I've got to draw a bar for China that's going to go up to 13. Of course, you'd use a ruler and a pencil, I hope. But here is mine, and it goes up to 13. Which of the countries produced 6.8 million tons? Well, let's have a look at the scale here. That's 5, so that's 6. So that's going to be 7 there. So 6.8 is about here, isn't it? And let's see which one it is. Aha, look. It is Brazil, isn't it? So which country? Brazil produced 6.8 million tons. In 2016, a total of 113 million tons of bananas was produced worldwide. What fraction of the 113 million tons was produced by India? Well, how much did India produce? Oh, look, here we go. India produced 29 million tons. So India must have produced what fraction? 29 out of the 113 million tonnes. So what fraction was produced by India? 29 113ths. Question 3. Complete the following sentences by writing a sensible, now look out, it says a sensible metric unit, doesn't it? Can you see that? So we need to write things like centimetres, metres, kilometres, maybe square units, but not things like miles. The distance from Cairo to Nairobi, well, I think that's 5,211 kilometers. The weight of an egg is 20 grams. And the area, the area of the floor of a classroom is 260 square meters. Now, let's have a look at this. Cara has a bottle of juice. There's 1 litre of juice in the bottle. I'm already doing some maths now. Read a question, read a sentence, do some maths. 1 litre, 1,000 cubic centimetres, isn't it? Or 1,000 millilitres. Cara makes some drinks. She uses exactly 30 millilitres of this juice to make each drink. Now I'm thinking that I could work out all sorts of things, like how many drinks she could make, or anyway, let's see. Cara makes as many drinks as possible. How many drinks does she make? Well, each drink needs 30 millilitres. So I'm going to see how many 30s there are in 1,000. I'll do that on my calculator. 1,000 divided by 30 equals, and I get the answer 33.333333. So she makes 33 and a bit drinks. So she can't make a bit of a drink, can she? So she manages to make 33 drinks. And that is question 3 done. Now let's move on to question 4. Here is a sequence of patterns made from square tiles. Pattern number 1, pattern number 2, pattern number 3. I'm thinking pattern number 1 has got a 1 here and it's got 2 there, hasn't it? This has got 2 of them there. It's got 2 here and 3 here. The next one, pattern number 3, has got 3 here and 4 here. So I'm thinking pattern number 4, right? So it's going to have the square on the top. Then it's going to have 4, 1, 2, 3, 4, and 5 down. 1, 2, 3, 4, 5. Complete this table. Pattern number, number of tiles. Let's just check. Let's look. They've given us this one. Pattern number 1 apparently has 4 tiles. 1, 2, 3, 4. Yes, it does. Pattern number 4. Oh, well, that's this one, isn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, I wonder if I can see what's going on here. 4 to 6 to 8 to 10. It's going up by 2 each time, isn't it? So the next one will be 10 plus 2. There must be 12. Or you could draw the 5th one if you wanted to. Work out the number of tiles in pattern 30. Well, we've got a sequence here. It goes 4, 6, 8, 10. Now, if we work out the nth term of that sequence, then we can work out the 30th term. Now, it's going up in 2s, so the nth term is 2n. Now, 2 times 1 would be 2, and my first one is 4, so it must be 2n plus 2. So there's the formula. And the 30th one then will be 2 times 30 plus 2. So 62 tiles in pattern number 30. Okay, that is question 4 done. Actually, that's not quite the whole of question 4 done, because here's it continues. Liz says that in pattern N, the number of tiles is 2n. Well, that's not true. We've already worked out it's 2n plus 2, haven't we? Is Liz correct? No. It is 2n plus 2, you could write. Or you could write, if it was 2n, then the first term wouldn't be 4. Any of those would be good reasons. And that is finally the end of question 4. Now let's have a look at question 5. Paul is buying a sandwich and a drink. You can have a cheese sandwich, or an egg sandwich, or a tomato sandwich. C, E, or T. You can have an orange juice, milk, or water. Write down all the possible combinations. Well, let's say he has a cheese sandwich, and then let's alter the drink. So cheese followed by orange, cheese with milk, cheese with water. That's all the cheese sandwich combinations. Egg sandwich with orange, egg with milk, egg with water. Tomato sandwich with orange, tomato sandwich with milk, tomato sandwich with water. Now, you haven't got to do it that way, but that way certainly works. And that's question 5 done. Question 6. Write a quarter as a decimal. Now, I hope you know that it's 0.25, but of course you could work it out on your calculator. Write 34 tenths as a mixed number in its simplest form. Well, again, you can do this on your calculator. Or you can say it's 3 4 tenths, which is 3 2 fifths. Now, this one you can't use your calculator for because it's a show that. So you must start with this, and we're going to work this out and hope that we get 4 fifths. So this is a division, isn't it? So we're going to keep, change, flip. Keep, change, flip. Now, top times top, 3 times 16, 48. Bottom times bottom, 4 times 15 is 60. And now, to be honest, I think you can use your calculator to cancel that. 48 divided by 60 equals, and that tells me it's 4 fifths. But strictly speaking, you could always say, look, I've divided top and bottom by 12. But I think you would get away with using your calculator there. And that is question 6 done. Question 7. Now, in this question, we're told that ABDE is a quadrilateral. We're told that ABC, here's ABC, is a triangle. And we're told that DCB, here's DCB, is a straight line. So it's all as it looks, but it's always worth reading those words. Work out the value of x. Work out the value of this angle here. Well, I see it's part of a triangle. 180 degrees in a triangle. So I'll do 180 minus 17 minus 125. 180 minus 17 minus 125 is 38. Give a reason for your answer. I think I'd probably write there are 180 degrees in a triangle. Next, work out the value of y. Give a reason for each stage of your working. Now, by the way, I know that's 38, don't I? Now, let's have a look. Well, I'm just going to work out what I can, really. And I think I'm going to start by working out that angle. Now, that is angle ACD. ACD. And it's going to equal 180 minus 125, isn't it? Because there are 180 degrees on a straight line. So, do that on my calculator. 180 minus 125. So ACD is 55 degrees. And I've got to give a reason. So I will say, in brackets, there are 180 degrees on a straight line. No, that one is 55. Let's write it in here. Now wait a minute. I can see what to do now. Do you see here to here to here to here is a quadrilateral, isn't it? And I've got 3 angles because I know that's 90. So the angles in a quadrilateral add up to 360. So that means that y will be 360 minus the other 3 angles. Put that in my calculator. Right. 360 minus 78 minus 90 minus 55. 137. I have to give a reason. So I think I would say the angles in a quadrilateral add up to 360. And that's question 7 done. Right, question 8. Simplify. Right, 6m. And then I've got plus 5m, so that's 11m. Now, how many k have I got here? That is minus 2k minus another k. 11m minus 3k. P equals 2 times A plus 3 times B. Work out the value of P. Oh, look, I'm told A and I'm told B. So P will be 2 times A, 2 times 5, plus 3 times B, 3 times 8. And you could just put that straight in a calculator and work it out. It's going to be 10 plus 24. So my answer is 34. Let's have a look at the next one. P is still 2A plus 3B. Work out the value of A when P is 16, so that's going to be 16 equals 2A plus 3 times 20. So 16 equals 2A plus 60. It's an equation. I'm going to swap it round and write 2A plus 60 equals 16. Now, I like floating and pinging here. I'm going to float and ping the plus 60, so it becomes a minus 60. So now I've got 2A equals, now 16 minus 60. 16 minus 60 minus 44. So I know 2A is minus 44. Divide both sides by 2, and A is minus 22. And that is question 8 done. Let's have a look at question 9. We're selling 240 ice creams for a total of $640. Crikey. Now, a third of the ice creams he sells are large. I can already do some maths. Let's work out how many large ice creams there were. A third of 240. Do that on my calculator if I want to. 80 large. The cost of each large ice cream he sells is $3.80. Okay. All the other ice creams he sells are small. Wait a minute, I can work out how many small ice creams he sells. Small, 240 is the total. 80 of them are large. Do that on my calculator. He sells 160 small ice creams. He sells each small ice cream for the same cost. Work out the cost of each small ice cream. Right, so you see here, each large ice cream he sells for $3.80. So 80 ice creams he sells for $3.80. So this is how much money he makes out of selling the large ice creams. 80 times 3.8. So he makes $304 from the large ice creams. He sells 160 small ice creams, but I don't know what he sells them for. But you know how he takes $640 in total? Well, $304 of that is for the large ice creams. So I'm going to do 640 minus 304, and now I know how much money he takes for selling the small ice creams. $336. And remember how he sells 160 of them. So each one, well, 336 divided by 160 will tell me the price of each of those. And the answer is 2.1 or $2.10. That's quite a tricky question, I think. I wish it said the price of each large ice cream he sells is $3.80, but it doesn't. Number 10. Write the ratio 32 to 80 in its smallest form. Now you can cheat a bit with your calculator. If you do 32 over 80 and press equals, it will cancel it down for you to 2/5. But what they really want you to appreciate is that you can divide each of these numbers like you cancel a fraction. But if I were you, I would put 32 over 80 in my calculator and press the equals button. There are only red counters and blue counters in a bag. Number of red, number of blue, 5 to 7. What fraction of the counters are red Well, it's 5 out of a total of 12. So that is question 10 done. Question 11. Right. We're asking 40 people where they went on holiday last year, and we're going to draw a pie chart. Now, wait a minute. If we're fitting 40 people on a pie chart, we know there are 360 degrees on a pie chart, so I can already work out how many degrees it will be for each of the 40 people by doing 360 divided by 40. So it's going to be 9 degrees for each person. 16 of the 40 people said they went to Egypt. Work out the size of the angle. Oh, okay. Well, that's going to be 16 times 9, isn't it? So the size of the angle for Egypt is going to be 144 degrees. Okay. Now it looks like we're on a different pie chart here. Tiffany asked some people what type of holiday they each liked best. She used her results to draw this pie chart. Okay, have a quick look at it. Some people like going to the beach, some people like walking, some people like the city, some people like touring. 48 of the people said they like beach holidays the best. So this here is for 48 people, this part of the pie chart. Right? How many people said they like walking holidays? Well, I think what I'd do is I'd say 48 people is 192 degrees. How many degrees for one person? Let's divide the 192 by 48. 4 degrees for one person. And it wants to know how many people prefer walking. So that's 56 degrees, isn't it? So if I do 56 divided by 4, then I can work out that 14 people must like walking the best. That's question 11 done. Question 12. Sam takes an English exam. There are 2 papers in the exam. Each paper has a maximum mark of 80. And Sam needs to get at least 60% of the total marks. How many marks does he need altogether then? Or maybe it's a she, I beg your pardon, who knows? So each paper has a maximum mark of 80. So that means there are 160 marks in total. And he needs, or she needs, 60% of them. So 60% of 160. That's how many marks are needed to pass. 96 marks to pass. Sam gets 55% of the 80 marks in paper 1. Ooh. How many marks is that? In paper 1, 0.55 times 80. 44 marks in paper 1. So, how many marks do we need now? 96 minus 44. 52 marks needed. 52 marks needed. So, work out the least number of marks that Sam must get in paper 2. Oh, I've done it, haven't I? Just by kind of guessing what the question would be. 52 marks on paper 2. That's question 12. Now, question 13, I'm not going to be able to do this because it all needs scale drawing and measuring, but I will tell you the answers because I've got the mark scheme in front of me here. Let's have a look at the answers here. So the bearing of S from P, what you have to do is you have to measure that angle. You'd probably better take measuring that angle and subtracting the green angle from 360. The answer is 310 because that green angle is 50, so the red angle is 310, and it's the red angle that's the bearing of S from P. They would have accepted anything from 308 to 312. A ship now sails directly towards port P. The ship sails at an average speed of 24 kilometers per hour. Work out how long it takes. Well, you need to work out the distance here. And you've got that there, they've got that scale. Okay? So, if you measure that line, how long is that line? I'm just trying to see from the mark scheme. Let's have a look. That line is 8.5. So, with any luck, you've got 8.5, and you times that by 20 to work out how many kilometers the whole journey is. And then you divide that by the speed, 24 kilometers per hour. So the answer should have been 7. But they accept anything from 6.9 to 7.3 in case your measurement of 8.5 was slightly out. And that is the marks to question 30. Question 14. I've got a point A and a point B, and I'm asked to work out the midpoint. So there's a set method for this. 5 minus 4 and 13, 1. What I do is I find the middle of the x coordinates. So I'm going to do them both added up and divide by 2. Gives me 9. And the middle of the y coordinates, minus 4 plus 1 equals on your calculator. That's minus 3. Divide by 2 gives you minus 1.5. Line L has that equation right down the gradient. Well, with any luck, you know that the gradient is the coefficient on the x. So the gradient is minus 3. By the way, the 2 is the y-intercept, but we're not asked for that. Line L has the equation y equals 2 minus 3x. Does the point with those coordinates lie on the line? Well, let's see. Let's put in x is 100 and see what the point would be on the line. It would be y equals 2 minus 3 times 100. Put that straight in my calculator. 2 minus 3 times 100 equals minus 298. So it's not on the line, is it? Because the point on the line with an x coordinate of 100 is the point 100 minus 298. Whereas the point they're asking me about is 100 comma minus 302. So it's not on the line. Does the point lie on the line? You must say no. Now, as regards your reason, I think that working would be enough. Question 15. Find the highest common factor of 28 and 70. Well, in this question, I'm going to use the calculator to write those in prime factors. Okay, now it depends how you do that, depends what calculator you've got. So I hope you know how to use your calculator to find these numbers in terms of their prime factors. Because in this question, you can definitely do that on your calculator because it doesn't ask you to show that part of the working. Now, when I find highest common factors, and look, I'm about to find LCMs as well, I always remember this. I always remember this Venn diagram here. If I have one of the numbers here and the factors of the other number there, I remember LCM and H goes up high, HCF. So to find the HCF, it's going to be those ones. So I'm going to put these factors in a Venn diagram. I'm going to have 28 here and the factors of 70 there. Now they've both got a 2 in them, and 28's got a second 2. 5 for there, and then they've both got a 7. So the highest common factor is 2 times 7, 14. Now let's do a similar process here. Now I've already worked out 28 as a product of primes, and I can use my calculator to work out 105 in prime factors. 3 times 5 times 7. So now I'll do my Venn diagram again. 28, 105. 28's got 2 squared there. 105's got a 3. 105's got a 5, and they've both got a 7. Now the LCM will be all of this lot. So it will be 2 times 2 times 7 times 3 times 5. So on my calculator, 2 times 2 times 7 times 3 times 5 equals 420. And that is question 15 sorted. Question 16. The diagram shows a shape. Yes, it does. The shape has an area of 129. Work out the value of x. Oh, well, here's x. Oh, maybe if I cut it off here, I could work out the area of that bit. And then, because I know the whole area is 129, I could work out the area of that bit. And maybe that'll help me get x. Let's try it. Let's first of all work out the area of the red. The area of that red rectangle is 9 times 12, isn't it? Use my calculator. 9 times 12, 108. So the area of the green must be 129 minus 108. 129 minus 108, 21, right? So the green has an area of 21. Now let's just have a look at the green. Here it is. Now, do you know what the height is? Do you know what that measurement is there? The whole thing is 9, and that's 6. That must be 3. So look at that. This rectangle, which measures x long and 3 high, it's got an area of 21. The area is 21, so that must be, x must be 7, mustn't it? Because 7 threes are 21. And that's question 16. Question 17. The table shows information about the weights in kilograms of 40 babies. Now, if there are 40 babies, then all those frequencies here, they should add up to 40, shouldn't they? So you can always check that. They do add up to 40. Okay. Write down the modal class, the most common class. The class with the highest frequency is between 3 and 4. Work out an estimate for the mean weight of the babies. Now, I've got 12 babies who weigh between 2 and 3. So I'm going to find the midpoint, 2.5, and I'm going to assume that those 12 babies weigh 2.5. In the same way, I'm going to assume that the 16 babies weigh 3.5, 9 babies weigh 4.5, 2 babies weigh 5.5, 1 baby weighs 6.5. Find the midpoints. Now, 12 babies each weigh 2.5, so I'm going to do 12 times 2.5 to find that total. 16 times 3.5 to find that total. 9 times 4.5 for the total of those 9 babies. 2 babies, 5.5 each. 1 baby, 6.5. Right. Time to get the calculator out. 12 times 2.5, 30. 16 times 3.5, 56. 9 times 4.5, 40.5. 2 times 5.5, 11. 1 times 6.5, 6.5. So to find the total of all the 40 babies, I'm going to add those up. Right. 30 plus 56 plus 40.5 plus 11 plus 6.5 equals. So the total is 144. Now, that's the total weight. What do I divide it by? I divide it by 40. Divide it by the number of babies. Gives me an average of 3.6, a mean of 3.6. Now, before I write that on my answer line, is that realistic? Is that a typical weight of the baby? I think it probably is, isn't it? At least it lies between 2 and 7, right? And look, it's about 3.6-ish, because so many of them weigh low down on that table, weigh a low weight. One of the 40 babies is going to be chosen at random. Find the probability this baby has a weight of more than 5 kilograms. Well, how many of those babies have a weight of more than 5? These guys do, and this one, 3 of them, isn't it? So the probability that the baby has a weight of more than 5 is 3/40. That is question 17 sorted. Question 18. 120 children go on an activity holiday. The ratio of the number of girls to the number of boys is 3 to 5. Wait a minute, let's do some maths. Girls to boys, 3 to 5. That's a total of 8, isn't it? There are 120 children in total. Work out what the 8's been times by. 120 divided by 8. So that means that we're going to multiply that by 15 and that by 15. So now I know that there are 45 girls and 5 times 15, 75 boys. Okay. On Sunday, all the children go either sailing or climbing. 9/25 of the boys go climbing. Wait a minute. I can work out how many boys that is, can't I? So climbing, 9/25 of the boys. So 9/25 of 75. This is how many boys. Did I say 9/25? I meant 16/25. So 16/25 times 75. 48 boys go climbing. Okay. So can I work out? Well, wait a minute, let's have a look. Twice as many girls go sailing as climbing. Okay, I don't quite crack that yet. Work out how many children go sailing on a Sunday. Well, I know how many boys climb. So the rest of the boys, 75 minus 48, 27 boys go sailing. 27 boys sail. Now I've got to sort out the girls now. How many girls are there? 45, aren't there? 45 girls. Now it says twice as many go sailing as go climbing. So sailing, climbing. Now twice as many go sailing as go climbing. So if I split the girls into 3, then I can put one of those shares here and 2 of the shares there. And then twice as many will be going sailing as climbing. 45 divided by 3, that's 15. So 15 go climbing and 30 go sailing. Now what's the question? Oh, how many children go sailing? Well, 27 boys plus 30 girls. So 57 children go sailing all together on the Sunday. And that's question 18, a tricky question 18. There. Let's move on. Question 19. What have we got here? On the grid, enlarge the shape with a scale factor of 1/2. Center 1, 2. So here's my center. It's got to have a scale factor of 1/2. So it's going to be half as big. And it's going to move here halfway towards the center. So that red dot is going to end up there. Let's do one more, shall we? Well, I could probably work out some of it from there. Look, you know how that's 4, so that's going to be 2. And you know how this is 1, 2, 3, 4, 5, 6, so it's going to be 3 up. And then you know how this is 1, 2, 3, 4, 5, 6, 7, 8, so it's going to be half. 1, 2, 3, 4. And now, actually, I can join it up. So I managed to do that. It wasn't very good. I managed to do that just by moving 1 point. And then because I knew that the new shape was going to be half the dimensions of the old shape, I could work it out from there. Question 20. Now you could probably use your calculator for this one, but I'm going to use my knowledge of decimals. I'm going to move the decimal point back 4 places. Now, 1 place, and then I'll have to move it 3 more places. So I'm going to end up with having to have 3 zeros after the point, and then the digits 7, 8. Now this one, I would probably just do this by putting it in my calculator. And I'd probably put it in my calculator all at once. So use the fraction button, and then I've got 5.6 times 10 to the 4 plus 7 times 10 to the 3. I'm putting all that on the top of my fraction, and on the bottom, on the denominator, I've got 2.8 times 10 to the minus 3. Press equals, and I get 22,500,000. So now I've got to put that in standard form. 2.25 times 10 to the power of 1, 2, 3, 4, 5, 6, 7. There's my answer for question 20. Question 21, expand and simplify. Right, I'm going to use crab claws for this. I'm going to go m times m, and then m times the 5, and then I'm going to go minus 8 times the m, and minus 8 times the 5. So m times m is m squared. M times plus 5 is plus 5m. Sorry, I've got messy here. I'll start again, shall I? M times m, m squared. M times plus 5, plus 5m. Minus 8 times m, minus 8m. Minus 8 times plus 5, minus 40. So I've got m squared, and then I've got plus 5m minus 8m. So that's minus 3m, and then minus 40. Factorize fully. Now I have to take out everything I can. If you just take out a 5, which you could do, then you haven't factorized it fully, because these two, the y and the y squared, still have a common factor. So I need to take out more than the 5. I'm going to need to take out 5y. That's going to leave me with 1 plus 4y. Simplify this. Oh, well, anything to the power of 0 is 1. And then the last part of this question, I've got this equation to solve. I'm going to expand that bracket first. 6x minus 15 equals 9 minus x over 2. Now, I'm going to escalate up the 2. Or you might prefer to say multiply both sides by 2. 2 times, got to times everything by 2. So that's going to give me 12x minus 30 equals 9 minus x. It's an equation with x's on both sides. See which side has the fewest x and get rid of them. Well, the left-hand side's got minus 1x. Well, that's the fewest x, because that's less than 12x. So I'm going to add x to both sides. 13x minus 30 equals 9. I'm going to float and ping the minus 30, or you might prefer to say add 30 to both sides. 13x equals 39. Divide both sides by 13. X equals 3. That is that question finished. Question 22, we're almost there. Here's a right-angled triangle. I'm thinking Pythagoras or trigonometry. SOHCAHTOA, let's have a look. Calculate the length of PQ. Right, I'm going to call it x. Now, I've got to decide. I can't use trigonometry because I haven't got two sides, so it's going to be SOHCAHTOA. Now, you'll have learned different ways of doing this. This is how I do it. I ask myself which side is not involved, because that's going to help me choose whether to use SOH, or TOA. Now, the opposite is not involved, and the SOH or TOA that doesn't involve the opposite is the CAP. So I know I'm going to use CAP. And in this question, I've been asked to find the hypotenuse. So I'm going to cover up the h, and that tells you that the h, the hypotenuse x, is equal to the adjacent over the cos. So I'm going to do x is the adjacent, 24.3, divided by cos 63. Stick that in my calculator, and that will be my answer. Let's have a look. 24.3 divided by cos 63 equals, give your answer correct to 3 significant figures. Well, my whole answer, or lots of my answer, is 53.5, 525, and so on. 3 significant figures cut off here, Does it round up? No, it doesn't. 53.5 is my answer for question 22. Well done for making it through to the end of that paper. I hope you found this film useful. Did you find it useful? Hit like and tell me so. Hit like, give me some positive feedback. Hit like as it helps YouTube spread this film to others who might find it useful. And if you've got any questions, please leave them in the comments. And of course, I'll respond. Thanks for watching. See you in the next film.